So we have a curve and a line given by the two equations. We have an x squared, negative xy, and quantity k plus 1 times x equals 1, k over 2 times x plus y also equals 1. And we know that k is a non-zero constant and intersects at a single point. So we have a parabola and a line intersect at a single point. We want to find the value of k. All right. So, no idea what to do. So first thing we're going to do is I'm going to take this y, solve for this y, and plug it into the equation. That way you're just trying to reduce the variables. So I'm going to start by saying that y equals 1 minus k over 2 times x. Yeah, that seems reasonable, even plausible. But I'm not as concerned with y as I am with xy, so I'll multiply both sides by x. And that tells us that xy equals 1. Oh, nope. Multiply everything by x. There we go. X minus kx squared over 2. And I'll do a little negative there. That gives us, I'll rewrite this just for convenience, kx squared over 2 minus x. Right. And the reason I went to this trouble here is now I can rewrite the top part, and I am going to rewrite it as kx squared, minus xy. Minus xy is going to be plus kx squared over 2 minus x plus kx. Maybe. I'll just do it. Yeah, I'll do this with kx plus x equals 1. And what I did was I solved this second equation here for y, and then actually negative xy, plugged in the top one, combined the two equations. So now we have this quadratic right here. I'm going to make it a little bit cleaner real quick. There's nothing deep mathematical going on here, just convenience, which I guess on a deeper level, math is just convenience. Alright, that cancels, and we have plus kx minus 1 equals 0. Alright, so now we're in familiar quadratic territory. So we're going to do the quadratic formula, negative b plus or minus b squared minus 4ac square rooted all over 2a. And plugging in our coefficients, we're going to have negative b, which in this case is negative k, plus or minus square root of b squared, which is just going to be k squared, minus 4, times a, which is 3/2 times k, times c, which is negative 1, everything square rooted, all over 2 times a, which is 3/2 k. We can do a little simplifying here. So get a good color for contrasting. Yep, I like green. Purple and green go together well. This 4 and the 2 becomes just a 2. The 2 and the 3 become a 6. The negative and the negative 1 become a positive. The 2 and the 2 cancel. And we are left with negative k plus or minus k squared plus 6k square rooted all over 2a, which is the same as 3k. Alright, so we are given another piece of information here, specifically that they intersect at a single point. And so if I draw a picture of these graphs, not going to be a good picture, a terrible picture. So parabola like that, and line like, I'll say like this. That's exaggerated and terrible. We're going to go like this. All right. Now, the thing is, it tells us it intersects at only one point, so we can zoom this down, and it might intersect like that, only at one point here. And these are the two drawn independently. The graph we created when we combined them in a quadratic like this, if this is our axes, it's going to look something kind of like I don't know, I'll do something like this, where it intersects the x-axis at only one point. So using that information, we can then address what we have going on here. So this part right here is called the determinant. You don't really have to know that name, just the concept. So a quadratic, a polynomial in general, is going to have as many roots, i.e. x equals 0 or y equals 0 at various points along the x-axis equal to the highest power of your polynomial. So to say that more simply, this power here, x squared, 2, we're going to have two solutions. And that's why we have two solutions here, 1 plus, 1 minus. Well, this says we only have one solution, so the only way we're going to get that is if this part right here, this determinant underneath the radical, underneath the square root, is 0. Because if, let's say, for example, x equals 2, so then x would equal 2 plus 0, 2 minus 0, it's all 2, it's all the same. You can add 0, subtract 0, nothing changes. And so we still technically have two solutions, they're just the same solution. And you can get 0 solutions when this is a negative number, because you can't take a square root of a negative number. Well, you can, but for the intents and purposes of this, without using imaginary numbers, we're going to pretend you can't, because that's not, yeah. Later, it is possible in life. That's not what they're implying. We're looking for real solutions of x. Did they say real solutions of x? So, yeah, we're looking for real solutions. All right. So, long story short, this part, middle, equals 0. So, k squared plus 6k equals 0. Dividing both sides by k, we get k plus 6 equals 0. K equals negative 6. Is that true? That seems true. All right. So one thing we need to be careful, though, is it 6 or negative 6? And we know it's going to be negative 6 because we know that k squared is going to be positive. And for this to equal 0, we know that 6 times k has to be negative. So 6 is positive, which means that k has to be negative to make this all cancel out equals 0. So we know that k equals negative 6 is the answer. Is that good enough? Did we just do this? Find the value of k. Yes, we totally did. So we could also find the values of x. So this gives us x. So if we plugged in, so we know this part equals 0. So just for a little completeness here, we could then find the x value of where this happens, or makes this true. And we have negative 6 all over 3 times negative 6. I guess I could just cancel out the k's. We get negative 1/3. So this solution is true at x equals negative 1/3. And we can plug it in here and then find the value for y too. Not a big deal. So key idea here, determinant, which is this right there. When there's only one solution for a quadratic, that means that this determinant, this portion under 0, under the radical, under the square root, has to equal 0. That's how you solve this problem. Hope that helped. See you next time.